Hello, I'm Sean Jordan, and I will be presenting Lab 1 for Physics 2212 charge tapes. The Glowscript for this lab can be found in the description. The purpose of this lab is to observe and determine the excess amount of electron charge on an ordinary object in standard conditions. And the main fundamental principles that are going to be explored in this lab are Newton's second law and Coulomb's law. So the objectives of this lab are to calculate the charge of the tapes, find the excess amount of electrons from these tapes, and find a ratio of atoms per electron emitted from each tape. This will all be calculated in Glowscript with a visual aid, and the setup for this lab will be the entire charge tape setup that you'll see in a later slide, and the surroundings will be everything else. Here are the main equations that will be utilized for the calculations, with the first being the electric force magnitude, the second being the idea of gravitational force, that being F equals ma, and the idea that these two forces in our system will be at equilibrium, so the net force will equate to zero. This is the setup for the experiment, and the process goes as follows. You first want to create two charge tapes by placing a base tape on a surface and a tape on top of that, and then you're going to rub that tape onto that base tape that was on the surface and rip off that tape that was on top. You can do this twice, and one of these tapes will be placed on scaffolding, and the other tape will slowly be raised underneath that held up tape, and you will see a phenomenon of the held up tape float. For this lab, some assumptions that we'll be using is the fact that the tapes are going to be acting as point charges, and air resistance from the surroundings is also negligible, as well as both the tapes being equal charge. After setting up this lab, the data at the bottom of the slide were measured, and you can pause to see those in better detail. Another part of this lab is to see how one of the charged tapes that we found when setting up the lab interact with other objects. So when two of these charged tapes interact, they repel each other. If a tape interacts with a hand, it will attract, and if a tape interacts with a pen that was ripped on a surface, it will also attract. Here are the initial conditions and calculations for the computational model. If you would like to look at it in greater detail for each value and how it was calculated, then you can pause here. It's important to note that the calculations for the charge of the tape utilize the rearrangement of the electric force equation shown prior. Moreover, the excess electrons are found by dividing the charge with the charge of the absolute value of an electron. After running all the calculations, the gravitational force was found to be 1.74 e to the negative 3 newtons, and by extension, this also equates to the electric force. The charge tape had a charge of 1.013 e to the negative 8 coulombs. The number of excess electrons was found to be 6.33 e to the 10, and the ratio of atoms per electron is 1 to 5.34 e to the 6. Here's the code for the visual aspect of the model, and you can pause here if you would like to see the coding for that as well. Some potential errors could be rounding errors from the calculations, assumptions that could skew the data, such as air resistance, and the tape measures being slightly inaccurate when inputting the width and length of the tape. Now, what if the proton and electrons flip charges? That being, the proton had a negative charge and the electron had a positive charge. Well, the signs would flip as a result and change the direction of the electric field and electric forces. However, in this case, for our experiment, because we're using the magnitudes, this doesn't really change much with our findings, and the experimental visual will remain the same. Now, why is it important to not touch the tapes as much as possible? This is because the tapes, which act as an insulator for electrons, can easily transfer to other objects if it interacts with them, weakening itself as a result. So it is best to handle them as little as possible to make sure it can maintain its electrostatic charge and to make sure the experiment actually works as intended. That is the end of this presentation. Thank you for watching.